Hello, everyone. I hope you all are doing well. Those who are watching me live, can you guys first of all confirm to me, am I clearly audible or not? And after that, maybe we'll start the session very soon within few minutes so that those who really want to join, they can join. Okay? But meanwhile, just do let me know whether my voice is clearly audible or not. I hope everyone already have seen from the thumbnail and the heading that we'll talk about the feature selection techniques in today's session. And first of all, we will see what is the importance of feature selection techniques. And afterwards, further, we will talk about that how basically we can do the implementation of those techniques. So, step by step, I'll try to show you the demonstration of everything. And after that, we will try to completely cover up the concepts of feature selection today. Moving forward, after some point of time, I'll try to organize one more live session where I'll try to cover up one more interesting thing regarding the feature decomposition techniques, like how we can decompose the features, right? So that is the another part of the session which I will cover up in the later part of the maybe this week or maybe the next week. I'm not sure about that. I'll let you know via my LinkedIn post in the community post. So please do connect with me via LinkedIn as well as stay tuned on my channel so that you will not miss any of the updates, right? But yeah, before start the session, can you guys, anyone, confirm to me, am I clearly audible or not? Is my voice as clearly audible or not? Can I get some sort of confirmation from anyone so that after a few minutes we can start the today's session? And after that, I'll start sharing my screen as well. Yep. Is everything so far so good? Am I clearly visible, audible, and is my screen is also visible to everyone? All set? Can anyone give me the confirmation so that we can start our today's session? I think it's 6:02. I will wait for 2-3 minutes more and then I'll start. Is my voice is audible? Anyone can give me the confirmation? So, in today's session, our focus is to talk about something called as feature selection technique. Now, the very first thing that we have to understand here is that why we need to select the features. What's the need for the selection of the features, right? I hope everyone must have heard this term called as curse of dimensionality. Curse of dimensionality. What is the meaning of that? The simple meaning is that if suppose we will be having too many features, if suppose we will be having too many features, sometimes what happens is that when we are training our model will not able to understand the important factors which are responsible to get the predictions. That is the very bad thing about having the multiple features, right? And in that scenario, what we usually want is we usually want that whatever features we know are really important, let's select that in a data pre-processing step itself. And after that, we will try to focus for the model training part and we will be able to get the predictions out of that. Okay. So, what is curse of dimensionality? Usually, when our feature size will get increased, it usually impacts directly inversely proportional as well. Sometimes accuracy drops down. And that's where either we have to select the features, or there is something also called as dimensionality reduction technique, which is a separate topic altogether. But usually people confuse between these two words, dimensionality reduction techniques. Have you guys heard of this term, dimensionality reduction techniques? Anyone knows what are the techniques that we have in dimensionality reduction? And what do you think? Is these two terms are same, or is there any difference between these two terms? When I'm saying feature selection and when I'm saying dimensionality reduction, is anyone aware about this fact that is these two terms are interchangeable, replaceable, or they are having a different inference, and at what point of time we should go for feature selection task and at what point of time we should go for dimensionality reduction task? Anyone who can let me know any dimensionality reduction technique which you are aware of? Can I get some response from anyone, those who are watching me live? So, PCA, yes, that's superb. So, when I'm saying dimensionality reduction technique, the next important objective of upcoming live will be PCA only. So, it's PCA, that's true. Okay, so I told you what is the difference between feature selection and dimensional reduction. In feature selection, what is happening is out of the given features that we have in a given data set, we are trying to select few features, right? We are trying to select few features. For example, you will be having a pool of features where you will be having feature F1, feature F2, feature F3, feature F5, feature F7, feature F4, until maybe 10 features are there. What you really want is you really want to have a subset of this superset features where you will take those features which are inferring the different important properties, maybe 3 features, maybe 4 features. You are selecting from this superset few features. Now the values of these features are exactly the same which you have in the original superset. Okay, so that is where you are applying a feature selection technique that we will learn today how we can do that. Okay, that we will learn today. When I'm saying second important word which I have used is dimensionality reduction. See, both are really important factors to get that curse of dimensionality thing. But in dimensionality reduction, what we are doing is we are trying to reduce our features in a way that we will try to originate some new features. What is the meaning of that? Suppose again you will be having a pool of features F1, F2, F3, F4, F7, F5, F6, F8, F10. Suppose again you will be having a pool of features. Now, when you applied a dimensionality reduction technique, maybe you have applied PCA. Okay. So, what is happening in PCA? You are trying to develop some new features, right? Via the concept of eigenvalues, eigenvectors. Maybe suppose you will say that I want 3 dimensions now. So, what you will do, you will originate some new features n1, n2, and n3, which is not exactly the same as the superset features that we have. That is the major difference between the dimensionality reduction techniques versus the feature selection technique. So here we will be able to get an altogether different set of features, okay, which is not similar to the features that we have. So this N1, N2, N3 will contain the properties of all the 10 features that I have in the superset. But when I'm saying feature selection technique, what I'm doing here is I'm trying to select few features out of the given features depending upon some properties that we have, that we will talk about later in a later part of the section of today's session. But is this part is clear to everyone? What is the difference between feature selection techniques and dimensional reduction technique? Is this concept is clear to everyone? So the simple meaning is they are not same and they are not even interchangeable. The concept is different altogether. In feature selection, we are trying to select from a complete superset of the features. We are trying to select few features out of that. In dimensionality reduction technique, we are trying to decompose our features in such a way that we will be able to originate some new features which contains the properties of all the 10 features that we have. That is the major difference between these two. Is this part is clear to everyone? Now, the next important part is how we can do feature selection. How will I able to select the features out of the given features that we have? Before talking about how, the first reason why we are moving towards the feature selection techniques, any thought about that? That why there is a need? The first thing which I have talked about is that we want to reduce the dimensionality, to reduce the dimensionality of feature space. That is the first point. We want to reduce the dimensions. We want to reduce the number of features, right? What will happen when we reduce that? Any idea? Why we are doing so? What's the reason behind that? What's the reason behind that? Why we are doing so? Obviously, when we will be having a limited set of features, you all know that the training time required for the model training per se will be less, right? And what we are trying to do here is we are trying to avoid the redundant features, right? Which are of no use in order to get the good accuracy. Now the question is how we can do so. How basically we will be able to get the features which are critically important for me to get the model's prediction. That's where the very first concept which came into picture is correlation coefficient heat map. Correlation coefficient heat map. So in this part, you required a knowledge of statistics. And I already have a playlist by the name of Statistics for Data Science where you can go and check it out this concept. But I'll try to talk about a gist of what is the literal meaning of correlation coefficient. Anyone who is aware about what is this correlation coefficient all about? Anyone who is having an idea, maybe they have already seen my videos or have learned from somewhere or have already implemented the concepts with respect to the correlation coefficient. What this particular parameter help me to provide with respect to the features? Any idea? Anyone? Whenever we are talking about correlation coefficient values. So in feature selection, the important thing is that you should be good with the stats concepts. If you're not good with that, you will again fail to understand the concepts pretty well. So anyone who is aware about the fact what is correlation coefficient in stats? Or maybe I'm not talking about the exact formula, give me the exact formula, how will it be evaluated? What I'm saying is, can you give me the inference, like what it basically tells to me? If suppose I will say that there are two features that we have and they are highly correlated, what is the meaning of that? What is the meaning of that when I am saying that the two features are highly correlated? So always remember that the correlation heat map value will lie from -1 to +1. And when you are saying, it means two features can be negatively correlated or it can be positively correlated. Now, if any two features are highly correlated, what is the meaning of that? If suppose I am saying that they are positively correlated, what is the simple meaning of that? The simple meaning is that if suppose I will be having feature F1 and on the y-axis I will be having feature F2, so the graph will look like this. Means when your value of F1 is increasing, the value of F2 is also increasing. That is the simple meaning of positive correlation. Okay. What is the meaning of negative correlation? And if suppose you will be having a value very close to 1, it means that two features are highly correlated, very close to 1. Now, when I'm saying negatively correlated, what is the meaning of that? What is the meaning of when I'm saying the two features are negatively correlated? The simple meaning is that if suppose we will be having these two features, this is a kind of a graph we will be able to get. What is the meaning of that? If suppose I will be having feature f1 and f2, if the value of one feature is increasing, the value of another feature is keep on decreasing. That is the meaning of negative correlation. The value will be approximately equals to -1. Now, listen this statement very carefully what I am saying. When the two features are highly correlated, at that point of time, the simple inference is that they're trying to give a similar kind of a information to the model to give the final prediction. When the two features are highly correlated, doesn't matter whether it be positively or negatively, they are trying to give a similar kind of information to the model's prediction. At that point of time, what we usually do, we usually try to remove any one of the feature. So if suppose I will be having two features f1 and f2, and if I'll say that these two features are highly correlated, so in that scenario what I will do, maybe I can remove any one of them, any one of the feature, because they are trying to give the similar information, they're trying to give the similar information to the model's prediction. So for the model's prediction part, they're trying to give me the similar sort of the information. That is something which you have to understand here. That's why it's really important to remove any one of the feature. Is this part is clear to everyone? So this is the very first way with the help of which we will be able to select the features. Okay. So what we will do is we will try to create a correlation coefficient heat map, and after that we will try to check it out. If there are any two features which are highly correlated, what we will try to do is we will try to remove any one of the feature, because anyhow it indicates that they are giving a similar information which is responsible for the model's prediction. Is this part is clear to everyone? Can you guys give me the confirmation? Now, how we can do so, I will show you the implementation as well. Okay, with respect to the first method that we have talked about, that is the correlation coefficient heat map, which is very helpful for us in order to make the selection of the features. So here, if you will observe, I will be already having a collab file which I will use in order to demonstrate to you regarding the very first method which I have just now talked about. So far so good. Shall I move ahead? Can you guys give me the confirmation? Can you guys give me the confirmation? If everything so far so good, shall we move ahead? Yes or no? Yes? Okay, perfect. So here, what we can do is, let's talk about the very first method implementation just now we have discussed. So for that, what I will do is, I will try to first of all import all the required libraries. Okay. So what we can do is, we will import NumPy as NP. We will import pandas as PD. We will import matplotlib, which is again really important, I believe, .pyplot as PLT. We will import Seaborn as SNS. So in this way, what we have done is we have imported all the required libraries of the packages that we have. Now what we can do is, I will first of all load the data set and will try to show you what my data is looking like. Okay. So now what I will do is, I will be having a data which is equals to pd.read_csv, and inside that I will pass the path of my data which I have. Okay. So now if you will be able to see my data, how it looks like this. So here we will be having battery power, blue, clock speed, dual SIM, and so on. Via this, what we are having is a final target value is price range. So I will be having a features of a mobile phone, and on the basis of that, it's a kind of a multi-class classification problem where we will be having a price range. Okay, where we will be having a price range. So if you will see how many price ranges we have here, so what I can say, set of data dot uh, price underscore range, and here you can see that we will be having four different types of price range. Either my price range belongs to 0 class or 1 class or 2 class or 3 class. Okay, so it means we will be having four different price ranges that we have. Now what we really want here, we really want to first of all split our data into two factors. So if you will see the shape of this data set, the shape of this data looks like this. We will be having 2000 number of records and 21 number of features, out of which the last feature is a target column, which is a price underscore range. So what I will do is, now I will try to split the data into independent, independent and dependent features. So what I will do is, or you can say maybe independent features and target values, anything you can write it down. So the value of x is something which is equals to data dot. I will take all the rows. I will use ilog function. And what I will do, I'll take all the rows and the number of columns will be from 0 to 20. The value of y is equals to, I will take all the rows and only the last column. So I can represent the last column by -1. So in this way, what we have done is, we have taken the value of x as all the columns that we have, starting from battery power to the last particular feature that we have, which is responsible for the prediction of the price range. And the value of y indicates the price range values. Okay, this is what we have. Now what I will do is, the very first thing which I will try to do here is, I'll try to create a correlation heat map. I'll try to create a correlation heat map, which I just now talked about. So what I will do here is, I will say plt.figure. I will define the figure size of that heat map. And maybe that will be equals to, let's say 20, 20. We will see how it will look like. Before that, let me give you one more idea about this function called as data.core, which we will use while creating a correlation heat map. Can you see? This is the values that we will be able to get. So in Python, we will be having a function called as core. This data.core function is helping us to give us a correlated coefficient value, correlation coefficient value. Now, if someone will ask you how this clock speed and battery power is correlated, what is the correlation coefficient value, you can easily able to determine that, right? So, and if you will observe here, the diagonal values all are equal to exactly 1. What is the reason behind that? The simple reason is, if you will observe here, the simple reason is that we will be having a same value on the x and the y axis. Obviously, the two features having a same value, for example, blue and blue, will always have a correlation coefficient value as 1. Similarly, battery power, similarly, clock speed, similarly, dual SIM, and so on. But with respect to other features, obviously, we can clearly able to see what is the correlation coefficient value that we have. And with the help of this particular function, we will try to create a correlation coefficient heat map. We will try to create a correlation coefficient heat map. Okay. So now what we can do is, let's move ahead and we'll try to create that. So now we have defined the fixed size, which is equals to 20, 20. Now what we can do, we can say x is equals to sns dot heat map. And here we can define this function data dot core. And what we can do, I want the annotation to be true so that the values will be written inside that. After that, maybe I will say plt dot, I can save this figure by the name of correlation coefficient heat map, okay, dot maybe png. And after that, I'll make it show. Okay. So now what will happen, once I will run this, you will be easily able to see a proper correlation coefficient heat map, where at every particular feature value, we will be able to see some number. That is the kind of a picture that you will be able to see here. Now, I will share this file with you all. And what you have to do here is to check that is there any feature which is very highly correlated. Here, if you will observe, with the help of this colors itself, we will be able to understand. For example, here if you will observe, we will be having price range, and RAM. Can you see that the correlation coefficient value of the RAM with respect to this price range is 0.92? It means that this is very highly correlated. But the good thing is that this is highly correlated with respect to the target value. It simply indicates that RAM plays a very important role in order to decide the range of the price, in order to decide the price range of any mobile phone, which is so true, right? If suppose any mobile phone is having a very high RAM, it clearly indicates that that mobile phone will be having a very high price as well. That is what you already, I hope everyone have observed as well. So we can see that how the two features are highly correlated. Similarly, here you can see 4G versus 3G. They are highly correlated with respect to a proportion of 0.58. But I can't see any feature, any two features which are having a value more than 0.92. So it indicates that RAM is a very important feature in order to get the model's prediction for the price range. Okay. So this is how basically we will be able to understand that how any two features are correlated. But the good thing is here we have to understand when I am saying that out of these F1 and F2 we will remove any one of the feature if they're highly correlated. Here I am talking about the features which belongs to X category, means any two independent features. If they are highly correlated, then you can remove any one of them. But as of now in the current scenario, what we have seen, the RAM and the price range are highly correlated. But in this case, RAM is an independent feature. RAM is an independent feature. I hope everyone knows here. But the price range that we have is the target value. So in this case, I will not remove this RAM feature. This is the target value. So I will not remove this RAM input feature. It indicates that this is a very important feature which is basically responsible for the price range of any mobile phone. So I will definitely take it up. That is the indication here. I will not remove RAM here. So the 2 points are quite different, and at the same time it's very important to understand. I hope I am making sense to everyone what I am trying to convey here. Even if you really want, you can just refresh it. You can download this image and you will be able to see the clear values at your home. So I will share the resources after the session with you all, and you can refer that. Or maybe I will ping in the comment section after the session, you can refer that. So this is the very first technique that we have, and that is about the correlation coefficient heat map, right? The second important technique that we have is about something called as selecting a k-best features. Selecting a k-best features. So with the help of a chi-square function test, with the help of a chi-square values, so we will be able to get a chi-square score values or score function. We will be able to get that what are the topmost maybe 10 features that we have in the complete data set which is responsible for the model's prediction. And then we can choose that as well. Now, what is this chi-square all about? For that, you should learn about, first of all, what is the meaning of a hypothesis testing concept, which I already have explained again in my stats for data science playlist, where we already have talked about what is the meaning of null hypothesis, what is the meaning of alternate hypothesis, and I will very soon publish one new video where I'll talk about the concept with respect to this hypothesis testing and this chi-square values. So with the help of this concept also, we will be able to check the correlation between any two features that we have. So how we can check that? Let me try to show you. So what you have to do is from sklearn dot feature underscore selection, what you need to do is you need to import something called as select k-best. Now, what you have to do from sklearn dot feature underscore selection, again, I am importing something called as chi-square. Okay. Now, my best features is equal to, I will call this model select k-best, which is responsible to select the best features. And here, what I am doing is I am passing the score function as the chi-square. as well as how many best features you want. Maybe suppose I want top 6 features which are really important for my model to get the predictions, accurate predictions. Now what I will do is I will just try to use this best features and fit on my x and y. Okay, I will fit that. Once it is done, I will be able to get the scores. So if I'll just write model dot scores, you will be able to see the scores of each and every feature that I have. Now, here if you will observe, what I can do is I can maybe write data scores, which is equals to pd dot data frame. I'm trying to create one data frame where I will try to get the features and corresponding to every feature, a score of that, so that it will make sense to us. Okay. So what I can do, I will just try to write model dot scores underscore in this part. And then we will be having the data column values, which is equals to pd dot data frame. And here what I will do is I will try to take the columns of x value, x columns. Okay, fine. Now what I can do is I will try to apply a concat function to concatenate this data score and the column value. So what I will say pd dot concat. And here what I will do is I will say, first of all, just write data column values. After that, just write data scores value. Okay, column wise I want, so x is equals to 1. And after that, what I can do is I can write the column names, feature scores, score dot column values is equals to. So the first column indicates the feature names, or you can say features. Second value indicates the score. And after that, what I can do is I can just display what is the value of the feature score we will be able to get. Now here you can see, what you can see here, if you will see, you will be able to get all the features, and with respect to every feature you will be having a score. Can you see that? Battery power, what is the score? Blue, what is the score? Clock speed, what is the score? Dual SIM, what is the score? PX height, what is the score? PX width, what is the score? So what is happening is, with respect to whatever 20 features I have, I will be able to get the score. What kind of score it is indicating? It is indicating that how much battery power is responsible for the prediction of a price range, how much this blue is responsible, how much this clock speed is correlated, how, with the help of this something called as chi-square function. Very important concept in stats again. Okay, now if suppose I really want to check it out, the top 10 features, suppose what is the top 10 largest score values which I have. So what I can do is maybe I can print in the feature score, give me the n largest values, where the value of n is 10, and or maybe let's take only 5, and let's say on the score column. So what will happen here? In the features, if you will observe that RAM, pixel height, battery power, pixel width, mobile weight. These are the topmost 5 features which are responsible for the price range prediction. Can you see that? And this is the similar kind of result that we will be able to get via correlation coefficient heat map as well. Do you remember that? I told you that when we are creating a correlation coefficient heat map that time also, what we got is RAM is having a very high correlation coefficient value, which was 0.92. Again, if you will observe, in this case also, RAM plays a very critical role, because higher the RAM, higher the price range. That's why the score is also very high. Is this part is clear to everyone? Is this clear? This is the second important technique that we have to select the features. Apart from this, there is another third technique that we have, which is commonly by the name of extra classifiers, which basically uses the concept of something called as decision trees, which we already have discussed in machine learning playlist. By the way, this video also which we are doing today is also coming under the category of this machine learning playlist only. After this mastering wine quality prediction, this video will be there. So you can refer it. Even those who are not joining live, they can also watch it in the recorded mode. Okay. So this is the complete idea. The third important factor that we have is something called as extra trees classifier, which again we can use. So that is again a extra tree classifier is a decision tree based technique only, where you can use sklearn.ensemble, where it is using multiple decision trees. you can import something called as extra trees classifier. And then what you can do is you can just train a model, maybe model 1, which is equals to extra trees classifier. And after that, what you can do is you can just fit this model, model 1 dot fit, on the value of x and y. Once it is done, what you will be able to get is the feature importance value. So what you can do is dot feature importance. Okay. So you will be able to get the every feature, what is the importance value that you will be having. Now, what you want is you want the again column value, the column value as well as the feature importance value. So what you are doing is you are saying, give me the model 1 feature importance value and the column value. So if I'll just print this part, what you will be able to get here is again the kind of a score where you can see battery power is there, blue is there, clock speed is there. Now again I can apply the same approach just like the above case, and what I can do is I can again get the top maybe 5 values. So what I can do is I can maybe say, give me the not feature score but the feature importance of the topmost 5 values. Let's say print that thing. Let's say what we will be able to get here. So can you see again I'm getting a similar kind of answer where we're getting a RAM as the topmost priority, then battery power. What was the result in the previous case? We are getting RAM. So if I just copy this and if I just paste it over here so that we can compare the results, I'm getting a RAM, I'm getting a pixel height, I'm getting a battery power, I'm getting a pixel width, and in this case I'm getting mobile weight. In the above case I'm getting a int memory. It means that somehow all the features are similar. It means that the topmost 5 features are almost similar. There is only one single feature which was there in this extra trees classifier approach, which was not there in the select k best model approach. So that is how basically we will be able to get via the technique number 3rd. So the third technique that we have discussed here is extra trees classifier model. Again, another very amazing technique which is basically gives us the importance of each and every feature. Above that, what we have used, the second technique was using the select k best model approach. So in this way we have discussed 3 amazing techniques that we have. The first technique was via using a correlation coefficient heat map. Second technique was via using select k best model, and the third technique was that is about the extra trees classifier, right? What about SVM? Where you will use SVM, Asad, in order to get the feature importance? So see, first thing is we will be having it's a classification problem. So if we're talking about that, you can use that SVM in the classification part. Yes, you can use that. But here the agenda is not moving ahead towards the training part. Here, what we are talking about is, here the simple agenda in this session is to talk about the feature selection part, which is a part of a data pre-processing. Okay. It's a part of the data pre-processing that we will do before model training. So here, majorly nowadays we are using these 3 techniques that we have discussed today, and apart from this you can try and explore other techniques as well, and do let me know in the comment section that what other techniques that we can implement here in order to get the critical features. But I hope now you will be able to understand that what is the meaning of feature selection. Means out of the given features, for example, if someone will ask me now that can you give me the 5 features, I want to select the 5 features out of all the given features that I have to get the prediction of the price range. So what I will select? Maybe I will select RAM, battery power, pixel width, pixel height, and int memory, right? On the basis of what models we have applied. I hope it's fine for everyone. Whatever things we have discussed, it's been 40 minutes. Do you have any sort of doubt? You can ask from me. Otherwise, I'll wrap up the today's session, and very soon I'll come up again and In that session, we will talk about something called as dimensionality reduction techniques, where I'll specifically talk about PCA in a very great detail. The major prerequisite of understanding that PCA part is that you should have a good idea about eigenvalues, eigenvectors, and internally, basically, what is the practical application of those concepts. Then you will really enjoy that session as well. Maybe you can suggest the timings of that session and the day on which you really want that session to happen in the comment section, because there are so many students who will obviously watch after the session will get ended in the recorded pace. So I really want everyone to get to give me suggestions of the timings which is very much preferable to you all in this week. Today is Monday, and I'll try to organize it in this week itself, if you will give me the suitable timings. Okay, ma'am, your teaching style is awesome. Thank you so much, Mohit. Thanks a lot. Is everything is so far so good? I'll try to share all the resources as well as the notes as well in the comment section, and will pin to them, so that everyone whosoever wants to utilize these notes, they can use that. Any doubts anyone is having? Anyone who really want to watch this live, they can just check it out in the machine learning playlist itself. The video will be there. No questions? Current time schedule is fine. I don't think it's fine, because usually there are many students who will join live with me, but today the audience is very less. So I really want that at least I will be having a good audience, so that it will be very good to interact with you all. That's the main purpose. Otherwise, I can upload the recorded videos as well. So just give me the suitable timing where the maximum audience will be there, so that we can interact. I can take your questions as well apart from these things, and I think that would be better. Okay, then, thank you so much, everyone, and I'll see you all very soon in the upcoming live. Till then, keep learning, keep exploring. Bye bye, and take care.